Welcome to another mobile H2O problem water video. This video will discuss a water analysis used to design ion exchange water treatment products. Ion exchange products include water softeners and spotless rinse units and other industrial treatment systems that you may be considering. The analysis you're looking at was taken from Lake Michigan water. We derived this analysis from the Chicago Water District, as you can see in the title up here, City of Chicago Department of Water Management, Bureau of Water Supply. The city puts out 4 analyses a year: first quarter, second quarter, third quarter, and fourth quarter. All municipalities are mandated to put out at least one analysis every year by the EPA. The analysis could be published or are published in May, June, or July, and most municipalities put them online. So you can look up, if you're in a particular municipality, you can look up your water. As you can see with this analysis, there are 2 basic sources of water, Lake Michigan that is, but there are different cribs. The City of Chicago has intake cribs out in the lake, about 1.5 miles out in the lake. And these are the raw water, where the highlighted are the raw water. And then the ones next to them, the points next to them, are sampling points throughout the city to make sure that the water is properly treated as it flows throughout the city of 3 million people. On the left-hand side, you have your parameters. And the parameters include temperature, turbidity, threshold odor straight, threshold odor dechlorinated, color, pH, free chlorine, saturated Langmuir index. We'll go over this in some other video. Alkalinity total, conductivity, bromide, chloride, fluoride, sulfates, hardness, calcium, magnesium, which are components of hardness, potassium, sodium, total dissolved solids, total solids. This includes floatables and other items like that. Total organic carbon, oxygen demand, chemical oxygen demand, ammonia is nitrogen, nitrate is nitrogen, nitrite is nitrogen, orthophosphate, phosphate, and cyanide. Now this column here is the maximum limit as recommended by the Illinois EPA. These are the particular ions, or the way they're looking at them. Of course, there's temperature, turbidity units, platinum cobalt color, pH is standard units. These are things that you can look up. If you want more information, give us a call. We're glad to talk about them. And then the center, as we go over again, these are the actual figures at the time of the analysis. So you can see along the bottom, there is an explanation of some of the technical points, not all of them, but some of the technical points are given here. So this is the first page. The second page is just a continuation. Oh, back to the first page. This is interesting, or something you should know. MGL stands for milligram per liter, or in the more traditional, part per million, milligram per liter or part per million. And the reason I went back to that is because this page primarily is in micrograms per liter. UG is micrograms, or parts per thousand. Many ions in the water are so small quantities that they can't measure them in the parts per million. They measure them in the parts per thousand. As you can see, aluminum, antimony, arsenic, barium, beryllium, boron, cadmium, chromium, cobalt, copper, iron, lead, lithium, manganese, mercury, molybdenum, nickel, selenium, silicon, silver, strontium, palladium, titanium, vanadium, and zinc. These are all items that the EPA, in a large city in particular, is concerned about. As you can see, these are the limits. Not all of them have limits stated, but for instance, if we looked at mercury, 2 parts per thousand. 2 parts per thousand, that's 0.002. So they will allow some of the water, but as you can see, this little signal, or this little indication here is less than 1. Well, that really means non-detectable. It's the amount of selenium in this case, or the amount of mercury. Well, mercury, that means there's not in the water at all. But the amount of molybdenum that's non-detectable. So anyhow, this is the analysis that you can get offline. You can go over it, and if you're sizing, let's go back to the first page. If you're sizing, say, a carbon filter for your home, these numbers here are important because they help you determine how much contact time you need. Not much. The City of Chicago's water only has one color unit, as you can see here, one color unit. That's not significant. It's slightly, just has a bit of color. And the same thing, and turbidity is another way of looking at a color, though they are different. So if you're doing a carbon filtration system, you might be interested in that. The Langmuir index is important for some rural areas where you might have high calcium, magnesium, or total hardness. That would indicate whether your water is scaling or non-scaling. The City of Chicago water is just barely scaling. As you can see, the Langmuir across it is quite low. It's negative, so that means it's non-scaling. And it's low too. So anyhow, we show you this is what a final analysis, or at least our interpretation of analysis. We would take the information on the charts and put them down on this grouping, this type of grouping to evaluate, and then we would do other manipulations to the numbers to get a useful product that we can size, or at least a useful number that we can use to size our products with. If you have any questions, please give us a call. We'd be glad to talk to you about these water analysis. And thank you for watching. Again, if you have any questions, please call. Bye.